So welcome back to the fourth video of the series. So we're going to continue with functions again, and today we can learn about another definition for functions that are called onto functions. So this is like we are defining functions. We are looking at different stages, the properties of functions. It's like describing a scenario. Okay, or looking at a child, how from the day he was born until he dies, how he grows, and the properties it has likewise. So we have to classify the functions like that, so that it is easier for us to use them in the future and to get an idea about the functions. Okay, so onto functions are called from earlier classes we know that the functions for a mapping to be called a function, it should be either one-to-one or min-to-one. So those are the two relationships that satisfy functions. So this entails all the members of the domain to be included in the mapping. All the members of the domain, so no one in the domain are left out. So this should be in your mind. Keep this in your mind. Do not forget this, that every element in the domain, X is the domain, Y is the codomain, every element in the domain is mapped, right? Everyone, so no one is left behind. It doesn't say that all the elements in the codomain should be mapped to. It doesn't say that. In addition to this, the unique member thing. So each X element should contain a unique Y, a unique element in codomain. So you have seen that when we calculate or try to guess the domain and the range, we know that in some cases the range does not equal to the codomain, in most cases actually. So the two options being either the range can be equal or it could be a subdomain of the codomain. So we know already that to categorize one-to-one and many-to-one functions, so there are two categories, one-to-one and many-to-one functions, and depending on this range being equal to or being a subdomain of the codomain, the functions can be further classified. Let's look at it. So this is an example. This is a one-to-one mapping, two scenarios. This is 1, this is 2. You can see here that the codomain consists y1, y2, y3 and y4. All 4 values are in the codomain and only 3 values are in the domain, right? So first of all, you have to make sure that all the elements in the domains are mapped. Yes, all 3 elements are mapped. But what about this? Are all the elements in codomain mapped? No, only 3 are mapped, 1 is left out. In this case, what happens? In this case, range is a subset of codomain. It is a subset of codomain, and still we call it one-to-one mapping. What about this? In this case, second scenario, still all the elements in the domain are mapped, so we are fine. What about the elements in the codomain? Yes, it has 4 elements and all these 4 elements are mapped by each element in the domain. So in this case, the range is equal to the codomain. Good. So these two are two different scenarios. These two are not equal. They are not equal. Why? First of all, because the domain has only here 3 elements and here you have 4 elements. So for two functions to be equal, you know that the codomain, domain and the rule, they all should be equal. Okay, this is one-to-one mapping, and this is many-to-one mapping. This is the other classification of functions, but we're going to dig deeper into the details. In this case, many-to-one mapping. Many-to-one means one y can be mapped by two or more elements in the domain, but still each element in the domain should have a unique y. Right? This is given. Each element in the domain, given that each element in the domain have a unique y, any element in the codomain can have at least one element, right? At least one element. Oh, sorry, don't think of it like that. Can have more than one element in the domain. But in this case, what happened here is that the codomain consists of 4 elements here, but y2, this element is left out, and y4, this element is also left out. Only y1 and y3 are mapped. What about this? In this situation, the codomain consists of 3 elements. All 3 of them are mapped. You can see here there is only one-to-one correspondence between these pairs, but still we call it min-to-one, right? So how do we define min-to-one relationship? If there are at least two elements mapped into a single y, it is called many-to-one, at least, right? So in this case, the range is equal to codomain, and in this case range is a subdomain, a subset of codomain. Okay, this is the definition of an onto function. Now we know that the range can either be equal to codomain or it can be a subset of codomain. The range of the function is equal to the codomain. When this happens, these functions are called onto functions. So this is written like this. Reciprocally, these are called onto functions. Okay, let's look at some examples now. This function here is mapped like this. Each element in the real set is mapped back into the real set. So here the domain and codomain both are real set, and the rule here is given as y equals 3x minus 2. So we have seen this. So this is a straight line. 3x minus 2 is somewhere here, so it goes like this. You know by investigation that any value in this domain can be applied to this, any value, and you'll be given a corresponding y value. So this line is continuous, which means all the elements in this y-axis also mapped. So all the elements in the y-axis means the codomain, right? Codomain in this case is equal to the range. Range is all the results, and codomains is all the possible outcomes. So this is called, since range is equal to the codomain, this is called one-to-one. Since we know this is a one-to-one relationship, because from the horizontal line test you know that it only cuts at one point. So this is one-to-one, and onto function, onto because this is true, right? Onto, one-to-one and onto. And now let's look at another example. Okay, try to see, just pause your video here and try to check whether this is an onto function or not, whether this is onto or not, right? So okay, so I think you got enough time to figure this out. Okay, let me just go through this. Here the domain is again the real number set, and the codomain is again the real number set. So what does this function look like? So this is a quadratic function. So here is minus 2, and the quadratic function goes like this, right? So what does this mean? This graph tells us all the result, not all the possible outcomes, the result of the function. So each values of x, for any value, or for each value of x, this is the corresponding y value. That is the meaning of the plot. You can see here that only y values above -2 are met. So these values of y are not met. So what does this mean? So the range here, range is what? Range is, so y is an element set of R, but the condition here is y is larger than or equal to -2. So I'm just gonna let me erase this thing. So here -2 goes like this. So the range here, try to do this on your own. So range is, so we define y, simple y, as an element in the codomain. So this is the notation. So R, this is an element in R. So if you leave it like this, which means y can be any element of R. But here after the comma, you put a comma here, then you write the condition. Which values of y are possible, right? So sometimes there can be several values, y values, that you cannot take. Several y values that you cannot take. Let's say y equals, this is not regarding this example. Let's say y cannot equal to 2, right? In this case, you just put this here. But this is not the case, so therefore the y values should be larger than or equal to -2. This is how you write the range. But the codomain is given as set of real numbers. In this case, these two are not equal, so this is just many to one function. Okay, next example. Okay, pause the video here and try to figure this out, whether this is onto or not. Okay, good. So let's look at this again. Now here the domain is taken as a set of all real numbers. Domain is taken as the set of all real numbers, negative, positive, integers, rational, irrational, everything. But the codomain here, they have defined it. They have defined the codomain as all the positive real numbers including 0. So when you draw the graph here, or you can try it algebraically even. So the minimum value should be y equals 0. You already know these things. So this is the graph. Y equals 3x squared. It goes like this. You can see here any y below 0 or any negative y values are not included in the functions. They are not included in the range, right? So only possible values are either 0 and all the positive real numbers. Okay, now in this case, you can write the range as, by examining this, you can write the range as this. What is this? This is also codomain. Okay, good. Now we know that this is many to one because of the horizontal line test. You have 2 points, many to one, and since the range is equal to codomain, this can be also called onto functions. So this is called many to one and onto function. Okay, I think this is the end of this video. So we'll meet again with another video, and if you have any questions, please send your questions to the group, WhatsApp group, and we'll discuss more examples on this in the next meeting. Okay, thank you guys.